You don't need complex poker math to win spin and goes. You only need one basic concept: pot odds. In this video, I will show you how to calculate them in seconds and how to instantly know whether a call is profitable or a mistake. Hey, and welcome everybody back to the poker math course, The Basics. I hope you are as excited as I am, because today we have our first lesson of the course. In case you have not watched the introduction to this course, now would be a good time to catch up on that. The topic for today, you see it on your screen, is pot odds. But you could have guessed it as well, because pot odds are often one of the first concepts players encounter when learning about poker and math, as they are an essential part of any successful poker strategy. At the same time, pot odds are also fundamental for achieving the goal of playing mathematically correct poker. So, without further ado, time to put your thinking caps on and join me on a journey into pot odds. Before we start with our pot odds journey, here you see our 3 guiding goals for this lesson. When you are not able to answer them after watching the video, something went wrong. Either my explaining was done not so well, or you lost track somewhere. If it's the second type, just rewatch the video until you can. In case of the first type, that my explaining was done not so well, I would recommend to join the TBP Discord server. It is free, it's awesome, and I'm a member there as well. So you can ask me anything unclear there, and I will try my best to help you out with your problem. Also worth mentioning, these 3 questions are not only our goals, they act also as our summary. Because at the end of this video, there will be no slide titled Summary, where I tell you what you were supposed to learn. Instead, you can take these 3 questions as a guideline and create your own summary. That way, I try to encourage everybody to actively work with the information presented here and not to just passively consume the information. To actively deal with everything presented here makes it way more likely that it sticks to your brain. Your own goal should be that my knowledge becomes your own knowledge, instead of just repeating some key points I listed for you. Everybody can be quite creative doing this by drawing a mind map or create some other sort of graphic, whatever fits your needs or comes to your mind. And remember, you can always share your summary on the TBP Discord channel with other members and get some feedback. Now, as we walk through the presentation, always have these 3 questions in the back of your head. Our journey starts very simple, by just looking at the name of the concept and what we can derive from it. You will see me doing this quite regular throughout this course, because everything we can derive from the name itself is information we do not have to actively remember. It is just information out there for free, and that is always helpful. Further, I picked 3 little pictures from 1 to 3, as you see on your screen, to point out every crucial element of pot odds. Starting at point 1. The pot in poker simply represents all the chips or money all players have put into it. To get a chance to win this overall pot, we have to individually contribute the amount we have to call from the last player who was betting or raising. So, with this knowledge, we can say, from our own perspective, the overall pot represents our reward, while our own payment can be seen as our risk. With realizing that, we can conclude that pot odds build a relationship between risk and reward. This fact is symbolized through the figure you see under 2. This relationship between reward and risk can be expressed through odds. How odds look like is presented under 3 on our slide. What all these numbers there explicitly mean, we will discover shortly. Finally, by just looking at the name and the three visualizations, we obtained everything what is there to know about pot odds. To put it in a nutshell, pot odds start with the pot itself. Then we realized they build a relationship between risk and reward, and this relationship can be expressed with odds. And that is actually everything you need to know about pot odds. On the upcoming slides, we will just fine-tune everything we already discovered up to this moment and look at everything from a different perspective. But the core, basic idea of pot odds presented here stays the same. On this slide, we see two ways to illustrate the relationship of pot odds as outlined before. These methods are denoted here. Under 1 on the left side, ratio method, and under 2 on the right side, percentage method. Let's begin with the ratio method. This method puts the pot size in relation to our call sizing using a ratio. A ratio shows in general how much of one thing there is compared to another thing, which is here obviously pot size to call size. As before, pot size is defined as all bets that have gone into the pot up to this moment, not including our own amount to call. While call size, on the other hand, is defined as the amount we have to pay or call. As with odds before, the pot size is our reward, while the call size represents our risk. So, as you hopefully recognized, the ratio method is basically the same as before the odds. On the right side, you see a second method to illustrate pot odds, which is called percentage method. As a percentage can always be expressed through a fraction, here in this case we have to divide the call size through the sum of the pot size plus call size. To understand the reason for that, we have to travel back in time to our school days. There, everybody should have learned at some point that when we have a fraction, the denominator represents always the whole, while the numerator represents the parts we are looking at. And the same applies here. Again, with pot size to be our reward and call size being our risk, we can substitute them in the formula on the right side and get to the last row where you see the fraction risk divided by the sum of reward plus risk. With that, we have defined both formulas for both methods, and which one you prefer to use is a question of preference, not right or wrong, because we will see that both methods are telling us exactly the same thing. I personally like to think in percentages, and later in this course you will see why. But it is absolutely crucial that you are able to switch back and forth between both methods. As this all was up to this point a little abstract or theoretical, let's look at an easy example and everything becomes a lot easier to understand. The simplified example goes as follows. William bets 2 BB into a pot of 8 BB. And now we want to figure out what are our pot odds with both methods. Again, we begin with the ratio method on the left side. The reward represents the pot size, which is all bets that have gone into the pot up to this point. This is, according to our example, 2 BB from William plus the 8 BB that are already in the pot. This makes a total pot or reward of 10. The risk is our call size, or what we have to pay if we call. This is in the example 2 BB. That gives us a ratio of 10 to 2. And now we can divide both sides by 2. And we get our final pot odds with the ratio method of 5 to 1. Pot odds of 5 to 1 mean we are risking 1 to win 5. Now let's turn to the percentage method. where risk and reward are the same numbers. With that, we put 2 in the numerator, and the denominator is the sum of 10 plus 2, which is 12. This gives us a fraction of 2 divided by 12, which equals 1/6 pot odds. Pot odds of 1/6 means we are risking 1 out of a total of 6. As you hopefully understand, both methods are telling us the same thing, just a little bit different. But if you're not seeing this, do not worry. It will even get clearer on the upcoming slides. On top, we see again the result of the simplified example from before. Now we're going to discover that you can transform the ratio result into the percentage result. To transform the ratio result into the percentage result is possible because there exists a mathematical relationship between both methods. You see this relationship on the bottom left inside the yellow circle, while the meaning of the variables is explained on the right side next to the yellow circle. There is nothing to understand here or to know where this formula comes from. Just remember what is inside of the yellow circle and you're fine. And it is more or less easy to remember because you just sum up your ratio and this becomes the denominator of your fraction from the percentage method. And you put the right side of the ratio on top of your fraction. And that's it. Sounds way more difficult than it actually is when you take out pen and paper and try it for yourself. You see, it's way easier than it sounds. But with that, up to this point, we discovered that both methods mean the same. The numbers can be transformed into each other. But if anyone still does not believe me that both methods are the same, I have one more way to convince you all. On top of the slide, we see as always the result of our simplified example. As we learned on the slide before, 5 to 1 equals 1/6. And what is 1 divided by 6? We can easily calculate this in our head, or hopefully you can, but I better take a calculator. And we get as a result 0.1666 and so on. If we multiply this number with 100, we get the actual percentage of 16.6. That percentage number is fairly easy to interpret because this tells us that we have to put 16.6% more in the pot when we call. That applies for both methods and both numbers. So 5 to 1 and 1/6 pot odds mean both that we have to put 16.6 more in the pot. With knowing that, we can even make one step further if we do some logical deduction here. So tighten your thinking caps. When we know we have to put 16.6% more in the pot, this can be interpreted as we have to win the pot in the same amount. Because why should we put anything into the pot that we are not expecting to get back? If we would do something like this, that can never be considered as mathematically correct poker. In real life, such a behavior would count as throwing money out of the window. And nobody wants to do this, not in real life or poker. So, with that clarified, the only thing left to figure out is a useful definition of pot odds. On this slide I listed a lot of possible definitions for pot odds that I found in books, papers or the internet. All of these definitions are true and you can pause the video, read them and think about when, why and how I highlighted each one of those in my presentation. What I personally dislike about these definitions is that they highlight some, let's call it, technical aspect of pot odds. But to me, that is not useful or easy to remember, even though they are all true. Imagine you are sitting at the poker table in the heat of the moment where you have to make a tough decision. How does it help you to know that pot odds are a risk-reward calculation or any other statement on the slide? That is why I like to use the following definition. This definition of pot odds you see right now is to me very practical, useful and easy to remember. So I would always stick to this definition. And by the way, we also showed that this definition is true as well. As a little bonus, this definition explains also why we took the path in our investigation we did. That concludes the core theoretical part for pot odds. And now let's jump to the poker tables and practice what we have learned. To figure out pot odds, it is especially in the beginning beneficial to follow a strict order, to not mix anything up or get confused. The order I would recommend or we use in the following examples is as follows. At first we grasp the situation. Then we determine risk and reward. Then we put our numbers in the formulas. With that, in our first example, we look at a heads-up spot on the flop where the big blind is betting and the small blind wants to know his pot odds. In this situation, the big blind is betting 6 BB into a pot of 6 BB, making it a total pot of 12 BB. As we know, the total pot represents also the reward. We know the reward is here 12 BB. As the risk is the call size, and that number is here 6, because the small blind has to pay 6 BB if he calls. Putting these numbers into the formulas on the right side, the ratio method on the right side gives the small blind a ratio of 12 to 6. We can now divide both sides by 6, which gives the small blind final pot odds of 2 to 1. Now with the percentage method underneath. There we put in the same numbers for risk and reward and get the fraction of 6 divided by 18. We can again divide both numbers by 6 and get small blind's final pot odds of 1/3. Both results of 2 to 1 and 1/3 are telling us that the small blind needs to win in 33% of the time. I would say not too hard, so let's jump right to the next example. At the second example, we look at a three-way situation pre-flop, where the button is min-raising, the small blind is calling, and big blind is 3-betting. And the button wants to know his pot odds. Next, we need to figure out the size of risk and reward. As always, reward represents the overall pot size, which is here 2 BB from the button min raise plus 2 BB from the small blind calling and 8 BB from the big blind 3-betting. If we sum up all these numbers, we get a total pot or reward of 12 BB. As risk is always the final call size from the player who wants to know his pot odds, which is here the button. So as the big blind is 3-betting to 8 and the button already contributed 2 BB to the pot, he has to pay or call 6 BB more. So 6 BB represents the button's risk. Now we can put these numbers into our formulas on the right side for both methods. As these numbers are exactly the same, as before. We get the same pot odds and results as before. So nothing more to learn from this example, so let's jump right into example 3. In our last example, we look at a 3-way spot preflop, where the button is limping and the small blind folds, and big blind shoves. Now the button wants to figure out what are his pot odds for calling the shove. First we need to know, as always, reward and risk. Reward is the total pot, which is here 1 BB from the button, plus 0.5 BB from the small blind, and 21.5 from the shove of the big blind. This sums up to a total pot of 23 BB. Risk is here, as always, the final call size, and as the button already paid 1 BB, he has to pay or call 20.5 BB more. Again, putting these numbers into the formulas on the right side gives the button for the ratio method a reward of 23 and a risk of 20.5. We can divide both sides by 20.5, which gives the button final pot odds of 1.1 to 1. And for the percentage method, we put in the same numbers for risk and reward, and then use a calculator to get final pot odds of 1 divided by 2.1. Both results in the yellow circle are telling us that the button needs to win in 47.1% of the time. So far so good, all the same as before, just the numbers are not that easy to handle, and that's why I chose this example to illustrate that it is okay to round when you get an uneven number. For the ratio method, we could take 1 to 1, and for the percentage method, you could round to 1 divided by 2. With that, both methods would tell us that the button needs to win in 50% of the time, which is close enough for our purpose, but way easier to calculate in the heat of the moment. That was our last example, and I hopefully could show everybody that calculating pot odds is not that difficult. It is always the same 3 steps to follow over and over again. And with a little more practice, nobody should have any problem with that. After understanding that, let's look a little ahead why pot odds are so crucial overall in poker. Pot odds are important because they are one part of a broader concept. If we use our definition of pot odds, they tell us how often we have to win, and this knowledge is one crucial part of getting closer to play mathematical correct poker. The other part is the knowledge of figuring out how often we actually win. This piece of information can be derived from the concept of odds, which we will discover in our next lesson. Finally, we arrived at the last slide, where, as I told you, is no summary. Instead, we want to look at how our lesson fits into the little helper chart. The 2 columns to the left, named bet size and pot odds ratio method, are taken out exactly from the chart. This was done because we saw in the presentation that our opponent's bet size was determining what pot odds we get. Under pot odds ratio method, you see what pot odds correspond with a certain bet sizing from our opponents. The column to the right, labeled pot odds percentage, shows our pot odds for the percentage method. With that given, everybody can use this table to practice transforming both methods. If you accomplished that, you can also add the bet size of your opponent as well. Your final goal should be to know when your opponent is betting 50% of the pot, you get 3-to-1 pot odds, which equals that you need to win the pot in 25%. Knowing this table inside out is already some valuable information for your poker game. So I wish everybody fun practicing with it, and that concludes the pot odds lessons. And everything left to say is thanks for the attention, and as always, good luck at the tables. Bye bye.